Bismillahirrahmanirrahim. Assalamualaikum wabarakatuh. Today we are going to cover chapter 3, process and process variables. Process is the most common operations that is actually happen in process industries. In process, we usually try to convert our raw material to the desired product by manipulating what we call as a process variables. So what are these process variables? We are going to look into that later in this particular lecture. But for today, we are going to look into very specific parameters that actually influence the properties of our process fluid. For example, the density and its associated specific gravity, the property of the liquid, solid, or gaseous species that we are actually handling, for example, their mass and the moles and relative parameters, for example, mass fraction, mole fractions, mass flow rates, and mole flow rates. And we are also going to actually look into how can we find a quantity by knowing other two quantities. So we are trying to actually solve for unknowns if we are given known values. Let's go back and look into the units that you had actually covered in chapter 1. We had actually identified various basic dimensions that is actually accepted under SI, but for the purpose of a process variables, we are going to look into 4 basic dimensions, which are moles of substance, mass of substance, time that they are actually flowing, as well as the temperature that's actually affecting the process parameter. We will also actually be going and look into the effect of a derived unit. The most important one is pressure, because pressure has a very high influence on the properties of a gaseous material, and the volume of our processing fluid are also actually affected by the amount of mass that we actually put in. So those are basic units and dimensions that we are going to look into in this chapter. Let's look now into what is known as a process. A process, as I described before, is any operation that converts raw materials into a product. It can be a system, as shown here, where you have various or sequence of major processes, or it can be a single unit, because in each single unit there are respective variables involved, and they are actually changing throughout the or along the sequence of the processes. So the common parameters that are actually involved in or the process variables that we are actually interested in are volume, temperature, pressure, mass flow rate, and its associated, and also moles. Let's now look at density. What is a density? Density is a very common parameters. You had learned this since primary school, and we had actually known the concept of density based on that discovered by Archimedes. So it is just a mass per unit volume. And the most important thing that we have to take into account is the unit, which are kilogram per meter cube, or the British unit is pound mass per feet cube. So density is denoted as mass over volume, or mass flow rate over volume, flow rate. Specific gravity is actually a dimensionless density value where it actually shows the ratio of the density of the material that we test at 20 degrees Celsius with the density of our reference at 4 degrees Celsius. So the most common reference material that is used to actually evaluate the specific gravity of material is water at 4 degrees Celsius. So can we change the reference density? Think about that. And the most common conversion factor, if you have different unit or the three known unit, is shown here. So you have 1 gram per centimeter cube, and that is equivalent to 64.43 pound mass per feet cube. So if you have 10 grams per centimeter cube and you want to actually convert it to pound mass per feet cube, then you are just going to times those with 62.43 pound mass per feet cube to get 624.3 pound mass per feet cube. Alright, the next parameter that are also important is flow rate. What is a flow rate? A flow rate is just an amount of mass or volume of material that's flowing from one point to the other. It can be any 2 points between two processing units shown here, or it can be from this whole system to another system. So the mass flow rate is just kilogram of fluid per unit time or kilogram fluid per second, and volumetric flow rate is denoted by V naught, and it is just a meter cube of fluid per unit time or meter cube of fluid per second. So we go back into the equation that I had shown before. It's density, rho is equals to capital M mass divided by capital V volume, or equals to m dot, which is mass flow rate, divided by V dot, which is the volumetric flow rate. Which of these parameters can be changed? What do you think? Which one should be and must be constant? Think of your conservation of mass theory. So we are going to look into that into our tutorial sessions through our worksheet. How do people measure flow rate of liquid in the process line? So these are the most common one. This unit here is a rotameter. A rotameter has a floating head, and as the liquid pass through, the floating head will actually rise to a certain level to denote the flow rate of the volume. Another one is what we call as an orifice meter. In the orifice meter, we have a small gap which actually obstruct the flow of the process stream, and here the pressure drop between the 2 points will be measured, and that will actually calibrated into the flow rate of the process line. There are other types of flow rate measurement or pressure measurement that we will actually look in the later chapter. Okay, let's move now to another most important property or process variables, which are chemical composition, which actually involve mole, mass, and molecular weight. So we know that all substances are denoted by their atomic weight, and you can actually get the value of the atomic weight from the periodic table, where the number is actually proportion to carbon 12. The molecular weight of a molecule is actually a summation of various atomic weights of elements that actually making up that molecule. So, for example, if the molecular weight of a species is m, then 1 mole has m grams. And the common terms that we use to denote the molecular weight of a substance is a gram mole, the unit is a gram mole or mole. And let's say if we want to actually convert a mole of substance to mass of substance, we have to actually multiply it with the molecular weight. And if we want to convert the mass of substance to mole of substance, then we have to divide it with the molecular weights. So these are the most common units that are used to denote the molecular weight of a substance. We can use it interchangeably by multiplying them using our conversion factor, and we have to make sure that the units are consistent. Okay, let's move now to what we call as a mass fraction. Mass fraction and mole fraction has similar concepts. They are actually defining the fraction or the amount of material with respect to the total amount of substance that making up a mixture. Let's say here we have a mixture of 3 different materials: propane, hexane, and methane. So if we want to know the mass fraction of propane in this sample here, which is denoted by A, then XA, which is the mass fraction, is equals to the mass of A divided by total mass of A, B, and C. It similarly should be done to B and C, and the summation of XA, B, and C should be equal to 1, and at all times XA, XB, XC should be equal to or less than 1. X as a mass fraction is most commonly used for non-reactive system or a liquid or a solid phase. For a gas phase or for a reactive system, a more common fraction that we use is a mole fraction. Similar to mass fraction, mole fraction is also actually defining the constituents of an element or of a substance with respect to the mixture in the substance. So we also denote it with a term we call it a Y, and YA plus YB plus YC should be equals to 1. And at all times, YA, YB, and YC should be equal to or less than 1. So for both type of calculation, if there are no information known on the given mass fraction or a mole fraction, then we should use a basis of a calculation to initiate the calculation.